This is test number 11. So the first question. Force capital F, density rho are combined as shown by F equals P over root rho. Dimensions of P is, so that they're asking for the dimensions of P. So this is the equation. F equals P divided by rho, root. So they have given that force is, capital F is force and rho is density. What they ask is dimensions of P. First, I'll subject P of this equation. So P equals F root rho. So since this is an equation, both sides should have the same dimensions. So we are going to find the dimensions of P here. Okay, so the dimensions of F is mass, LT2 minus is acceleration, minus 2 is acceleration. So LT2 minus rho, but it is within a square root. Dimensions of density should be ml minus 3, but it is within root. So I put a power half here. ml minus t times m, just multiply by the power L minus 3 over 2. Then just add the powers. Capital M 1 plus half, that is M 3 over 2, L 1 minus 3 over 2. So 1 minus 3 over 2 should be minus 1 over 2. Then T minus 2 is there. There's no minus 2 here. So this is the simplification. So it should be M 3 over 2, L minus 1 over 2, L minus 2. So the answer for that should be the second one for the first question. Okay, the second question. Measurement that cannot be taken by a screw gauge but can be taken by a vernier caliper is. So the screw gauge cannot take that. So you know the screw gauge. So we can, for example, it could be micrometer screw gauge, but this measurement should be able to taken by a vernier caliper. If you think about diameter of a sonometer wire, you know, that is a thin wire, just a thin uniform wire. Using a screw gauge, the screw gauge, micrometer screw gauge can be used to measure the thickness of a sonometer wire. Vernier caliper also can be used. The external jaws of the vernier caliper can be used. So that cannot be the answer. Diameter of a metal sphere, both can be used to measure the diameter of a metal sphere. Depth of a hole. Depth of a hole, you cannot measure that using a micrometer screw gauge. There's a part in the vernier caliper which is called the depth probe. Depth probe. I put the images. Depth probe. Using the depth probe, you can measure the depth of a hole. But screw gauge has no such part to measure the depth of a hole. If you remember the theory is there. So the answer should be the third one. Depth of a hole only can be measured using a vernier caliper. The third question, they have given the measurement taken by a micrometer screw gauge. So they ask what is the measurement shown by that micrometer screw gauge. So they say the pitch of it is 0.5 millimeters. And the circular scale is divided into 50 parts. So first thing you have to find the least count of this measurement. So if you remember, to find the least count, the pitch, that is 0.5 millimeter, should be divided by the number of parts, that is 50. So this is 0.1 divided by 10, then it becomes 0.01 millimeters. So the first thing is you have to figure out the least count. So that is 0.01 millimeter. Okay, then the measurement. Okay, so the measurement taken by like such apparatus is equal to measurement taken by the linear scale. Measurement by linear scale plus measurement by circular scale. Circular scale. Okay, so from the linear scale, what should be the measurement? So here, this mark is a 5 millimeter mark. 5, 6, 7, 8. So this mark should be 8. And each millimeter is divided in half. So this should be 8 millimeters, and for the other mark it should be 8.5 millimeters. Up to 8.5 millimeters we can measure using only the linear scale. So the linear scale measurement should be 8.5 millimeters. Up to 8.5 millimeters you can measure. So to measure the remaining part, we need the circular scale. As you can see, to find for that one, we first have to find the coinciding part in the circular scale. Here, the coinciding part is, as you can see, that is 45, 47, 48, 7, then 48. 48th mark of the circular scale coincides with this midline. So the coinciding part in the vernier scale is 48. To get the measurement, you have to multiply that 48 by the least count. So the least count here is, we found that 0.01 millimeters. Then the sum of these two should be the answer. So this is 8.5 millimeters plus 0.48 millimeters. So if we add 48 millimeters here, it is 8, 9, so 8. So you just have to add these two. Then it is 8.98 millimeters is the measurement taken by this, shown by this apparatus. So the answer for the third question should be the second. In the fourth question, from top of a tower, the ball A is dropped. B and C are projected horizontally with distinct velocities, meaning different velocities. If the time required for balls to fall is T1, T2 and T3, so they're asking for a combination between the times. Okay. So from the same place, the balls A, B and C are projected. The ball A is just dropped, so it just falls. Initial velocity is 0 for A. For B and C, they only have a horizontal velocity component, so they fall like this. For B and C also, they only have horizontal velocity, so the vertical velocity of B and C is 0. So for all three, initial vertical velocity component downwards is 0. Initial vertical component downwards is 0. C has a higher horizontal velocity component, but it is not for C as well. Initial horizontal velocity, that is downwards, is 0. So for A, if you apply, so usually we use this equation to find the time required. So if I apply that for A, let's say this height is capital H. Capital is equal initial velocity 0 half gt square. So the time is 2h divided by g root. 2h divided by root g. Like, so this is for A. Even if you apply the same equation for B and C, you would have the same conditions. initial velocity is 0. Horizontally downwards, initial component velocity is 0. Acceleration same, that is gravitational acceleration. Then you would get the same expression, that is 2h over g. So regardless of horizontal velocity components, the time it takes to fall down is the same, should be the same for all three. So the answer for that should be the third one. Fifth question is about projectiles. Two objects are projected from the same place with angles 30 and 60 degrees with horizontal. If both objects gain the same maximum height, ratio between their initial velocities are. So they are asking for a ratio between the initial velocities. Ratio. So I'll say one is projected at an angle 60 degrees, other one at angle 30 degrees. Let's say their velocities are u1 and u2. So you have to compare these velocities. But if the question says both gets the same maximum height, they both gain the same maximum heights. So for this one, height could be capital H. For this also, the maximum height is same. Maximum height is the same. So they have given that. So for this, I just simply have to apply, if you remember the projectiles, to find the maximum height we applied v squared u squared equation. 2as vertically upwards. Now for the first case, if I apply that, you know that at the maximum height, vertical velocity component is 0. Final velocity, I'm applying that from here to here. Vertical velocity component is 0. Initial velocity component vertical is u1 sine 60. u1 sine 60 squared. And minus 2gh. H is the same for both. Then I can say 2gh equals u1 sine 60 squared. Then for the second case, if I apply that, for the second case as well, vertical component at the maximum height is 0. Initial velocity is u1 sine 30 now. Now it is sine 30 squared minus 2g. For that one as well, maximum height is same. So I'll say that is capital H. So for that one, 2gh equals u1 sine 30 squared. So if you observe these two equations, 2gh same. So u1 sine 60 squared and u1 sine 30 squared should be also the same. So if the squares are same, right? So here u1 sine 60 squared equals u2 sine, here u2, right? u2 sine 30. Then I can say u1 sine 60 equals u2 sine 30. So sine 60 is root 3 over 2. Sine 30 is half cancels off. Then u1 cross multiply, u1 over u2 is equal to here 1 over root 3. So the ratio should be 1:3 between u1 and u2. So it should be 1:3. So the answer for the fifth question should be the third one. This question. A child on end of a boat with length 4 meters and with mass 225 kilograms slips and falls to water. Then father weighing 75 kilograms, who is on the other end of the boat, runs at constant velocity to the end where the child goes. then the distance between father and child is. So we have this board. So there are many ways to solve this question, but the easiest way is to solve this question using center of gravities, right? Center of gravity of the system. Okay, the child is here, the father is here. The weight of the boat, I'll just mark it. So the center of just the boat without father and the child. For just the boat, let's say the center of gravity is right in the middle, right? So for this point, has a mass 225 kilograms. So this is the mass of the boat. I just mark it here. Then here's the mass of the father, that is 75 kilograms. Just consider that to be like the center of gravity of the father. O1 and O2. 225, then 75 kilograms. So the child was here. So the child falls onto the water. Then father runs towards this direction to reach the child. But what happens is the boat tends to move to the opposite direction. As the father moves to this direction, boat moves to the other direction in order to conserve the momentum, right? But we are going to explain this using the center of gravity of the system. Okay, so the child is here now, right? Child is here. Okay, so so you have to consider two cases, when the father is here and when the father is here. Then you can compare those two cases and know the distance that the boat has moved to here. Okay, first for this system, for the boat and the father, for that system, you have to think about the center of gravity. So for this one, this is the one mass, the other mass. So you should know that this ratio between this distance should be 75 to 225 kilograms. So 75 to 125 kilograms means 1:3. So this is the distance ratio between between O1 and O2. So that should be 1:3. So the ratios between distances that you should know by the theories, right? Okay, then it is 1:2. Then they have given the length of the boat, that is 4 meters. If the length of the boat is 4 meters, this distance should be 2 meters. It is half of the boat, so it should be 2 meters. Then you have to figure out this length. So this length should be, let's say that length is x. So that x should be 2 meters is the whole length from here to here times. So this is 1/4. 1:3 means 1/4 of 2 meters should be x. So that is how you can calculate the lengths, right? So it is 1/4. 1/4 is come from like 1 plus 3, 4. Then this 1/4. So this is 2 meters and 0.5 meters. So x is 0.5 meters. Now imagine the situation when father is at the other end. Now father runs to the other end. Then the center of gravity should be moved by 0.5 meter amount. So the system is to the opposite side now. So this is 0.5 meters now. So in the first case, the center of gravity of the system was here. Now it moves another 0.5 meters. So the center of gravity of the system has moved twice 0.5 meters. So it should be 1 meter center of gravity. Where the father moves to the other end, center of gravity moves 1 meter. But the thing is, if you think about the system, which includes father and the board, as a one system, there is no external force acting on the system due to the action of father. So the system cannot change its position of center of gravity relative to the ground. So in this case, what should happen is the boat, the whole system has to move to the opposite direction by a 1 meter. So descent moves to 1 meter here. So as the father is to rescue the child, boat already has moved 1 meter to the opposite direction. So the answer for that should be the third one for the sixth question. That is the distance between the boy and the father as father reaches to the other end of the boat. I just briefly explained. There's like so much descriptions, but you just have to know the theories behind this, right? Then you can figure out the answer there. So for the sixth question, the answer should be the third one. Seventh question. Two identical objects moving at +2 and -5 collides perfectly elastically. Velocities of them after collision is. So we have these two identical objects with the same mass. They should have the same mass. Collides. They are moving 2 meters per second, 5 meters per second, then collide. I will say the opposite direction to this direction. Then they gain velocities, let's say they gain velocities v1 and v2. So what they ask is the velocities after collision. There's a shortcut method to find this, which I'll explain later. First, I'll simplify this using basics. But if you just use basics for an MCQs, it takes a long time, right? Which you will understand as I'm simplifying this. Okay, for the collision, since it's a collision, I can apply linear momentum conservation. So using a linear momentum conservation, velocity is 2 times mass, positive direction here. So this has a momentum which is negative. So -5 times m. Velocity times mass. Here, mass, velocity v2. From this -3, so if I divide whole equation by mass, you get -3 here, and the other side v1 plus v2. Likewise, you got a one equation which includes v1 and v2, that is equal to -3. So still we cannot find the velocities. We need another equation. So for that, I'll just apply energy conservation. For this one, we can use energy conservation because they say this is a perfectly elastic collision. So these have kinetic energy. So for kinetic energy, in the first case, half m velocity squared plus half m 5 squared equals here half m v1 squared plus half m v2 squared. Then I'll divide the whole equation by half m. You can get rid of half m. What you get is 2 squared, that is 4. 5 squared is 25 equals v1 squared plus v2 squared. So this is the second equation. So for the second equation, that is 29 equals v1 squared plus v2 squared. Okay, now we have two simultaneous equations. Then you just have to simplify these two simultaneous equations and find v1 and v2. Okay. So I'll just rewrite this one, v1 squared plus v2 squared is equal to 29. Then from first equation, I can take that V2 is equal to minus 3 minus V1. Okay. So V2, just put V1 to the other side. V2 equals minus 3 minus V1. Then I substitute this part here in the V2. Then you can get 29 V1 is squared plus minus 3 minus V1 is squared. Since this is in a square, this just gets positive, right? Whole thing gets positive. Squared equals 29. Then 29 equals V1 squared plus take square these two, so this becomes 9 plus 6V1 plus V1 squared. So then 29 minus 9, that is 20, equals V1 squared 2V1 squared plus 6V1. Then divide the whole equation by 2. This becomes 10 equals V1 squared plus 3V1. Then put this 10 up to the other side, you get V1 squared plus 3V1 minus 10 equal to 0. Okay, finally we got this equation. That is equal to 0. So we got a quadratic equation here. So you have to factor the quadratic equation. So this is 10. So this should be minus 5V1, 2V1. I got 3V1 as 5V1 minus 2V1. Minus 10 equals 0. Take factors from these two, V1 plus 5 minus 2 V1 plus 5 equals 0. V1 plus 5, V1 minus 2 equals 0. Then we get, so for V1 we get two answers, right? Here for V1 we get V1 equals minus 5 meters per second or V1 equals 2 meters per second. So here is the tricky part. So we got two answers for this. For V1, so we have to omit one of these answers. The answer which is not possible, you have to get rid of that answer. Think about V1 equals 2 meters per second. So initially also this was the V1 means the velocity of the first object, this object. Initially this has 2 meters per second. Even after collision, can it have the 2 meters per second? Even after collision. After the collision, its velocity must change, right? So it cannot be, after the collision velocity also cannot be 2 meters per second. It has to change. So this answer should be omitted. V1 cannot be 2 meters per second. So V1 should be minus 5 meters per second. Meaning, after collision, this object moves to the opposite direction at 5 meters per second. Okay, then, so once you know V1, the answer for V1, then use first equation, then substitute it here. So the first equation is minus 3 equals V1 plus V2. Minus 3, so V1 is minus 5 plus V2. Put 5 to this side, this becomes 2. So V2 is 2 meters per second, that is a positive answer. Okay, so after the collision, we found values V1 minus 5, V2 plus 2. Minus 5 meters per second, then V2 is plus 2 meters per second. So those are the values. Okay. So the answer for that should be the second one for the 7th question. Second one for the 7th question. So as you can see, this consumes a lot of time, right? There are some things that you should know when there's a perfect elastic collision. Always relative velocity between objects is equal before and after collision. So if you know that, you can shorten the time taken for this, right? But this is the usual method to solve this. Okay, so the answer for the seventh question is second one. Eighth question. In a perfectly inelastic collision of two objects, relative velocity of objects is 0 before collision, 0 after collision. Equal before and after collision, never 0, always 0. So those are the options given. So there are some things that you need to know about perfect inelastic collision. Perfect inelastic collision means when objects collide after collision, it has the maximum energy loss. It doesn't mean the objects stop when they collide. What it means is those objects have the maximum energy loss. So such a collision is called inelastic collision. Perfectly inelastic collision. So for something like that, let's say this object has velocity v1, the other one has velocity v2. So after collision, to have the maximum energy loss, this is the possible way to have that. The objects should attach together. We can prove that. So you just have to know that, right? In a perfectly inelastic collision, the objects should attach together and move with the same velocity. When they attach means after the collision they move with the same velocity. Let's say velocity v. So in such case, these have the maximum energy loss. So you just have to know this, right? There's no time to prove this. You just have to know this, so you can use them in MCQ. Okay, so if after collision both have the same velocity, so what's the relative velocity between these two? It is 0, right? So after collision, relative velocity between them is 0 in a perfect elastic collision. Both have the velocities to the same side. So v minus v. So that is the relative velocity between them. If they are attached, relative to them, they have no velocity. So the relative velocity after collision should be 0. So the answer for the 8th question should be the second one. 0 after collision. Okay, 9th question. Inside a lift, a mass is hanged by a spring balance. Difference between scale readings when lift goes up at 6 meters per square second and when it goes down at 5 meters square second is 15 Newton. Mass attached to the scale is. So there's this lift. Then there's a spring balance, and from the spring balance there's a mass attached. Let's say mass is simple m, so the weight of the mass is mg. So if you reading of a spring balance is always, you have to remember this, reading of a spring balance is always the tension here, tension between the weight and the spring balance. You can always use this. So this is the reading. So at the first case, lift goes up at 6 meters per square second. Lift goes up at 6 meters per square second. And at the second case, lift goes down. Let's say the reading is T1 in the first case. I'll draw for the second case. Let's say the reading is T2. same mass, right? So a same mg, but the reading changes because now it is moving downwards at 5 meters per square second. So the whole thing is moving downwards at 5 meters per square second. So you just have to apply first F equals ma to each case. I'll apply for the first case. Since it is moving upwards, I'll apply F equals ma upwards. So this is T1 upwards minus mg equals m acceleration 6. So this is the first equation. Then I'll apply F equals ma to the second case. It is going downwards. So I'm applying it downwards. So this is downwards mg upwards T2 equals m times acceleration is downwards, that is 5. So this is the second equation. But what they have given is the difference of readings. That is, that should be T1 minus T2. In order to make T1 minus T2, I'm going to sum add these two equations. So you get T1. This minus mg and plus mg cancels off when you add the equations. Then this becomes T1 minus T2. This minus T2, that is equal to m times 6 plus m times 5. If you add them, it should be 11m. So difference of readings T1 minus T2. They have given that as 15 Newton. So 15 Newton equals 15 equals 11m. So m is equal to 15 over kilograms. It is given it can be given in kilograms. That is 15 over 11. So it is somewhat like 1.3 is remaining. For 3 there are 2, 22, then 8 is remaining, 8, 7. So it is, the answer should be the mass attached is 1.27 kilograms. 1.27 kilograms. None of the answers match with this one, so I have given all for that answer, right? Yeah. For the correct answer for that should be 1.27 kilograms. I have given all for that question, okay? Next question, 10th question. Masses simple M and capital M are pulled separately by the same force on a smooth horizontal plane. When each moves the same displacement, ratio between their kinetic energy is. Okay, so we have a simple M mass, then we have capital M mass. Both terms horizontal planes, so there is no friction acting on them. To both, same force is applied. Let's say capital F. So what they ask is the kinetic energy gained when they are moved a distance simple s. Let's say the distance is simple s. So initially both are at rest. So you should know that there's no friction acting on any of the objects. Their mass are different, but the thing is the force and s is same. So you have to understand the work done on both is also same. So the work done here is Fs, right? Here also Fs, regardless of their mass, force and distance applied. Then this work becomes the energy gained by each. So that work converts into the kinetic energy. So the work done for both is same. So both converts into kinetic energy. There is no friction. There is no any energy loss. So the work done for both is same. So the kinetic energy gained in each case also should be the same. So kinetic energy gain here and kinetic energy gain here should be the same. But the velocities could be different because these has like different masses, right? So the work fully converts into the kinetic energy. So the answer should be the ratio. If the kinetic energies are the same, the ratio between the kinetic energies should be 1 to 1. But the velocities are different, right? Velocities gained here and here is different because the masses are different. But the kinetic energy gain should be the same. So the ratio should be 1 to 1. So the answer should be fifth one. Okay, 11th question. An object moving at root 3 meters per second can just penetrate a wood plank. Speed required to just penetrate 3 wood planks is. So this also can be solved easily using energy conservation. We can use the linear motion equations and Newton laws as well, but energy conservation is easier to solve this. So let's say this is one of for the first case, this is the wood plank. And let's say it has a width or thickness, simple x. Then the object penetrates through this one. So as it penetrates, just penetrates, right? Let's say it has a velocity v and the mass is simple m. So it just penetrates and the velocity here just becomes 0. Meaning the kinetic energy that the object had is completely lost when it reaches to the other end as it just penetrates. So as the mass moves inside the block, there's a resistive force acting on the mass. Let's say that resistive force acting on the mass is capital F. So this is the kinetic energy it had. Kinetic energy. Then let's say the kinetic energy that is equal to the work done by the resistive force. So the mass stops. So this is the kinetic energy of the mass. Since it stops due to the work done by the resistive force. Okay, that's why it just penetrates. So I'll just apply. So they say the velocity is root 3 resistive force F and it moves x distance. So this is the first case. So for the second case, what they ask is if you have 3 such planks, if you have 3 planks, the distance it has to penetrate is 3x. So I'll apply the same equation. Let's say same mass, same the velocity. Let's say the velocity is v. So this has f times 3x. Same resistive force, but the distance it has to move is 3x. Then I just divide by 1 and 2. Half m cancels off. Root 3 squared is 3 divided by v squared equals fx is 1, f3x is 3. Then cross multiply. V squared equals 9. So v is equal to 3 meters per second. So to penetrate just a one plank, it needed root 3 velocity, but to penetrate 3 planks, you need 3 meters per second of velocity. So the answer for that should be the second one for the 11th question. 12th question. 5 blocks A, B, C, D and E with masses 1, 2, 3, 4, 5 in order placed on an inclined plane, and the inclination is increased gradually if the static friction coefficients between plane and each box are 0.5, 0.4, 0.3, 0.2 and 0.1. The box that first starts slipping is. So we have 5 cases, right? So when you get a case like this, you have to create like one module for the whole thing. So you are not going to solve 5 questions, right? For each cases, you are not going to solve each case, and you have no time for that. So when you get a question like this, you have to get a general model for all, which I will do. So this is theta, inclination. I'm taking any mass, let's say mg. So you know, if you get the components of mg, this component is mg sine theta, this component is mg cos theta. Then we need capital R, normal reaction force, and there's this friction, capital F. So what we do is we increase the inclination. At a certain point, at a certain inclination, this starts to slip. Just let's say that like just it starts to slip meaning that limiting case, right? Limiting friction. So at that particular inclination, it starts to slip. Just it starts to slip doesn't mean it is slipping downwards. It is a limiting condition, right? So for the limiting conditions, you can apply this equation. F equals mu1. So I'll just apply that. F equals mu1 here. Since this is in equilibrium, you can see this is not moving, so this is in equilibrium. F equals mg sine theta. Friction is equal to mg sine theta. If you get the force equilibrium along the plane, so just substitute it here. Mg sine theta equals mu. R is, if you get equilibrium of forces normal to the plane, this R is equal to mg cos theta. R mg cos theta. mg cancels, so sin theta equals mu cos theta. Then mu is equal to tan theta. So what does this say? This theta is the angle in which that the object starts to slip. It totally depends only on the friction coefficient. Friction coefficient. So it does not depend on the mass. So these objects have different masses, but just don't think about the mass. You only have to think about the friction coefficient between the plane and each mass. So what they ask is, which object starts to slip first? So from this equation you can see higher the mu, higher the theta, meaning higher the friction coefficient, higher the inclination that requires for slipping. Okay, so which one has the smallest friction coefficient? Yeah, for the box E, right, has the smallest friction coefficient. So also, if it has the smallest friction coefficient, it also should have the smallest angle required. I mean, the smallest inclination required in order to slip. Okay. So if you keep increasing the inclination, first E starts to slip. It starts to slip, right? So the answer should be the 5th one for the 12th question. Then 13th question. An object slides down at constant velocity on a plane with the inclination theta. If the object is placed at the bottom of the plane and projected up along the plane at velocity u, maximum distance that the object moves is. Okay, so there first they have given an object along an inclined plane. They say that the object moves at constant velocity, meaning that this object should be in equilibrium. So what are the forces acting on the object? Mg components, mg sine theta to this side, mg cos theta. There must be a friction acting on the object which will be the kinetic friction since it is moving. Then there is a normal reaction force capital R. So those are the forces acting. Then they say, at the second case, object is shot upwards at velocity u. Object is shot upwards at velocity u. So this obviously has a friction. So the same friction is applied here. Same friction is applied here. So from this equation, you can see that the friction and this force should be balanced because it is moving downwards at constant velocity. So friction equals mg sine theta. So we have a equation for friction. So we have this equation for friction. Friction is equal mg sine theta. They haven't given anything about mu and r for friction coefficient. So we have to use this equation from the first case. Friction equals mg sine theta. So what they ask is the maximum distance that it travels along the plane. Let's say the distance is s, maximum distance. The easiest way to find this is using energy equations. We can use linear motion equations, but using energy equations is easier. Right. So let's say this is P equals 0 level, potential energy 0 level, and at this point all it has is kinetic energy and is given as U. So this is half mu squared, kinetic energy here. So that kinetic energy is used as, let's say the object stops here. So it is the maximum distance it moves along the plane. So the object should stop here. That kinetic energy converts into the potential energy. So this height, you have to think about the height. So that height is S sine theta. The height is, this is hypotenuse, so this height should be S sine theta. Then mg is sine theta. I will say sine theta times S. But this is a plane with friction. So as it moves along the plane, this kinetic energy is lost as friction as well. So this kinetic energy should be equal to potential energy plus lost energy due to friction. So the lost energy due to friction is work done by the friction, which should be friction times distance it traveled, Fs. That is the work done by the friction. Okay, so this is half mu squared mg sine theta times S plus F, friction. We have this term. From the first case, we can get mg sine theta times S. So this is mg sine theta S plus mg sine theta S. So it should be 2 mg sine theta times S, half mu squared. M cancels off. This is if you cross multiply, this becomes 1 over 4 u squared. Then this sine theta, g sine theta, that is S. So S is equal to u squared over 4g sine theta. So this is the maximum distance it travels along. So this became like kind of easier because you used energy conservations. But if you use like linear motion equations and F equals ma, those stuff, this will be like a bit complicated, right? Yeah. So the answer for the question should be the fifth one for the 13th question. A wheel with mass 40 kilogram and radius 0.5 meter is rotating at angular velocity 1800 rpm. Then it is stopped by applying a constant torque within 30 seconds. Magnitude of the torque is. Okay. So we have this wheel. Its mass is 40 kilogram. The radius is 0.5 meters. And it has the angular velocity 1800 rpm. Then they say by applying a torque to the opposite direction, let's say torque is torque, to the opposite direction, this is stops within 30 seconds. Okay, first you have to do some conversions and some calculations. First, I have to convert this into radians per second. 1800 R means revolution. One revolution in radians, it is 2 pi. This is per minute. Meaning you have divided by a 1 minute, which is 60 seconds. 63 and 30 times 2 60 65 radians per second. This is the initial angular velocity. Okay, then I'm going to find, we'll need the moment of inertia of the wheel. So I'll calculate that as well. So for a wheel or a plate, moment of inertia can be found using half mr squared. Mass is 40, r is 0.5 squared. 20 times 0.5 means 102, squared means 104. So this is 5. So moment of inertia of the wheel is 5 and the angular velocity it has is 60. Right. Then they say within 30 seconds, if you apply this torque, it stops within 30 seconds. They have given it as time, right? So we cannot involve energy equations with time. So because of that, we need to find the angle that it rotates before stopping. So to find, I'll use this equation. Okay, final velocity is 0. It stops. Initial velocity is 60. Divided by 2, the time is 30. So this is 15 times 60. So 15 times 2 is 30, 30, 90. Now we know the angle that it rotates before stopping, that should be 900, right? 900 radians. It rotates 900 radians before stopping. So 15 times 2, 30, 30 times 3, 90, then this 0, 900, 900 radians. Okay, then I'm going to apply energy equations. So the kinetic energy this had, that is half I omega square, kinetic energy of the wheel, is completely lost due to this torque. It is the torque, work done by the torque. Work done by the torque is tau times theta. Then that work should be equal to the kinetic energy of the initial kinetic energy of the wheel. Okay, then just have to substitute these values. I is 5. Omega square, that's the initial velocity, 65 squared. Tau times theta is 900. Half 5, 60 times 60, 5 squared divided by 900. These two zeros cancels off. 3, 2, 3, 2. 2 cancels off. 2 times This is 900 pi radian, right? Because it's 60 pi. Then we have 4 times 900 pi. 2 times pi, one of this pi cancels off with this one. Then 2 times pi, 5 is 10 pi. So the torque is 10 pi Newton meters. So this is the torque to be applied, 10 pi Newton meters. So the answer for the 14th one should be the first one. 15th question. An object with mass m and radius r and gyration radius k rolls without slipping at speed v. Its kinetic energy is. So this should be kind of like a plate or could be a sphere. So this rotates and the speed of this is v. So you know that tangential velocity also should be v. So what they ask is a kinetic energy of this object. So for objects that are rolling without slipping, so they are rolling and they are moving ahead. So these types of motion has both linear kinetic velocity and rotational kinetic velocity. So for linear velocity, I can apply half mv squared. This is for the transitional motion, which is linear motion. Then another one is rotational motion, half I omega squared. mv squared plus half this I, that is the moment of inertia. You know that it can be found mass times square of gyration radius. So when you have, so as these equations, mass times square of gyration radius. So that is equal to I. So I have substituted here, that is omega squared. Half mv squared plus half m k squared. This omega squared. We know that v is equal to r omega. V is the tangential velocity, that is equal to r omega. Then omega is equal to v over r. So we substitute v over r here. So this becomes v squared over r squared. Then take half mv squared out from each. So this becomes 1 plus half mv squared. What is remaining inside is k squared divided by r squared. And it should be half mv squared. So this is the total kinetic energy of rolling object. Rolling object means it has both rotational kinetic energy. It rotates as well. It has a transitional motion and rotational motion. That's why we have to like add both, right? So the answer for that should be, that's match with this one, is second one for the 15th question. Half mv squared 1 plus k squared divided by r squared.